Today what we're going to talk about is simplifying radicals. When we simplify radicals, we're going to need a radical sign, and this is a radical sign, commonly known as a square root sign. And the reason, because a lot of times we write it and there's no number there. But it's understood that if you do not have a number here, there's a 2 there. The number or the factors that are inside are called radicand. What we want to do is make sure that when we have numbers or variables underneath the radical sign, that there is no perfect square. These are the perfect squares: 4, 9, 16, 25, 36, 49, 64, and 81. And once these numbers are under this radical sign with an understood 2, the numbers above them are going to be their roots. We call these the square roots. Let's take a look at our first example, which is the square root of 16. And remember, we know that there's an understood 2 here. Is 16 a perfect square? Yes, it is a perfect square. And we look right above it and we see that the square root of 16 is going to be 4. So what we're going to do is we're going to have a parenthesis and put 2 on the outside and put the square root on the inside. Now, we know there's an understood 2 here, and this is just what we want. We want the 2 with the square root sign, and we want the 2 on the inside. And whatever is inside of the parenthesis is going to be our square root. So the answer is going to be 4. Let's take a look at the square root of 25. Is 25 a perfect square? Yes, it is. The square root of 25 is 5. So I'm going to rewrite that. There are my parentheses. I'm going to put my 2 on the outside, and we said that the square root of 25 is 5. And we know the square root of 25 is 5 because 5 times 5 equals 25. So therefore, that makes 5 the square root. So since 5 is inside the parenthesis, that is going to be our answer, 5. Now, we can also have variables that are perfect squares. Anytime you have a variable that has an exponent that's even, it's going to be a perfect square. And what I'm going to do is I'm going to put that x in parentheses. And so as you see, the x is now in parentheses. The 2 is on the outside. So therefore, our answer is going to be x. Once again, we have another example where we have an even number, 16. Okay? I'm going to put x on the inside. And notice I've left room for the exponent to go here. Put a 2 there. Now 2 goes into 16 8 times. So I'm going to put 8 on the inside. The 2 always goes on the outside, and you're going to divide 16, whatever exponent this is, by 2. And as we said earlier, whatever number is inside the parenthesis, that's going to be our answer. So we're going to get x to the 8th power. Now let's see what happens when we have an exponent that is odd. You're still going to work it the same way. You're going to have your parenthesis with your x. You're going to leave room for your interior exponent and put the 2 on the outside. Now 2 goes into 7 3 times, so my exponent here is 3, but I have 1 left over, and that 1 tells me I have 1x left over. So I'm going to put my x right here. And what I'm going to do, I'm going to highlight it. I'm going to make it red so that you'll see that that is the leftover factor, x. Now, as we said before, whatever is inside the parenthesis, that is going to be our perfect square, or our square root of our perfect square. And so that is going to give me, take the x cubed out, x cubed times the square root of x. Let's work a few more problems. Example 6. Let's do the square root of x to the 23rd power. Okay? So I'm going to put x in my parenthesis, leave room for the exponent, always 2 on the outside. As long as this is a 2, understood 2 here, we always want a 2 there. Now 2 goes into 23 11 times with 1 left over, and that is going to be 1x. So when I simplify this, I'm going to take out this perfect square which is x to the, the square root, which is x to the 11th power, and that x is going to stay inside. Now, let's see what happens when the numbers are not perfect squares. Let's look at the square root of 8. All right, you don't see 8 up here as a perfect square. But let's see if there is a factor of 8 that is a perfect square. We're going to start dividing by 2. And 2 goes into 8 4 times. Is 4 a perfect square? Yes, it is. So I'm going to separate my factors here and make that the square root of 4 times 2. Now, since 4 is a perfect square, I can put my 2 on the outside, and the square root of 4 is 2. And I'm going to put what's left over here times 2 on the outside. All right, so my answer is going to be take out what's inside the parentheses, which is 2, and I'm left with times the square root of 2, which is left on the inside. Let's do a few more. Let's do the square root of 48. All right, let's see if there's a factor of 48 that is a perfect square. Let's start by dividing by 2. Start with the lowest number. And 2 goes into 48 24 times. And 24 is not a perfect square. So let's try the 3 next. 3 goes into 4 once. That's 3, 18. And 3 goes into 8 6 times. And 16 is a perfect square. So we're going to factor that out. That gives us 16 times 4. Now, let's put our 2 on the outside parenthesis. And the square root of 16 is 4, so that goes on the inside. And I'm sorry, that should be a 3. I'll go ahead and write it in red. So that's going to give me 4 squared times 3. Now, inside the parentheses, I have a 4, so I can take the 4 out, and I'm left with the square root of 3. Now, I bet you're asking, can we mix it up? Can we mix up the numbers, or include the numbers and the variables? Yes, we can. Let's look at example 9. Let's have the square root of 75, a squared, b to the 7th. All right, let's start with about 75 to see if we have a perfect square hidden in there. Well, we know 2 can't go into 75 because 75 is odd. So the question is, can 3 go into 75? It's 2 and 5. And we get 25, which is a perfect square. So I'm going to break that up to 25 times 3 times a squared b to the 7th. All right, now let's start putting everything in parentheses with the 2 on the outside. So that's going to give me the 2 on the outside there. And the square root of 25 is 5. And then we're going to multiply that by 3. Because we can't throw it away, we have to include it. All right, now let's look at our A. All right, 2 is on the outside. 2 goes into 2 one time. So we're just going to leave it there because we know there's an understood 1 where the A is. And now let's look at our B. Put the 2 on the outside. 2 goes into 7 3 times. And I have 1 B left over. So I'm going to put the B here. Now let's see what factors are inside the parentheses. We have a 5, we have an A, and we have a B cubed. And we're going to factor that out so that we get 5A, B cubed, and what's left under the radical sign is going to be 3B. All right, just for fun, we're going to work one more problem, and we're going to have quite a few variables under there. Last example, example 10. And we're going to review our rules. square root of, let's do 108. Let's do a to the 7th. Let's do b to the 3rd, c to the 4th, and let's let d be to the 17th power. All right, we're going to follow the same rules that we discussed in the very beginning. See 108 here. Is it a perfect square? No. Is there a perfect square that is a factor inside of that 108? Well, let's divide and see. 2 into 108 goes 54 times. 54 is not a perfect square. Let's try 3. It's going to be 3 times. It's 9, 18, 6. So we have 36. And is 36 a perfect square? Yes, it is. So the first thing I'm going to do is just factor out my perfect square, which is 36 times 3, 8 to the 7th, b cubed. I'm just writing these variables over. Now I'm going to start putting everything in parentheses. So that is going to be squared here, square root of 36 is 6. And then I'm going to have the 3 left over. All right, let's look at my A. I'm going to put in parentheses. 2 goes into 7 3 times, and there is 1A left over. Let's look at B to the 3rd. I'm going to put the B in parentheses. 2 goes into 3 1 time. There's an understood 1 there. And we have 1B left over. This is a nice long problem, isn't it? But we're reviewing the rule over and over again. That's the whole point. Let's look at C, parentheses, C, 2 on the outside. 2 goes into 4 twice, and there's no remainder. Now let's do D, parentheses, 2 on the outside. 2 goes into, that should be a 17. 2 goes into 17 8 times. And there's 1 left over, so we're going to put a D there. And I'm going to change that to red because I forgot. Okay, now let's write our answer. Everything inside the parenthesis is going to come out such that I have the square root of 6, a cubed, b, c squared, and d to the 8th. Let's scrap that, my bad. Let's make that 6, a cubed, b, c squared, d to the 8th. That's what comes out the, from underneath the radical sign. And what's going to be left is 3a, b, d. Okay, so those are our rules. We have, if we have a number, we have to see if there is a perfect square that is a factor, and we have to start with 2, then divide by 3, 4, 5, and so forth to make sure we have a perfect square. We don't have one, and then we separate it, and then we just bring down the other variables, and then we start putting everything in parentheses, and then what's not in parentheses just goes on the outside. Then whatever's in parentheses, we take that out from underneath the radical sign, and we leave the others in under the radical sign.